Yeah, thank you very much. Thank you very much for this very interesting presentation, going really into the experiment and showing the type of data acquisition tools that we need and data processing tools that we need. And it's great that we can collaborate on this, I think. So far, I don't see any question in either the Q&A. Ah, there is one raised hand. Matthias, you want to take over?
Yes, so Julia Galli has a question, and Julia, please.
Hi, I have a question. So you talked about the the needs about data science and how not to make it an afterthought, of course. My question is, do you see any needs in the development of theoretical tools, of any of the theoretical tools, for example, that could come from our electronic structure community or simulation community that combined with, of course, data science, machine learning and whatnot, could help you? Or you see your problem as first and foremost just a data science problem?
Well, thank you, Julia, for the question. No, what you're saying is correct. We obviously for X-ray, both X-ray spectroscopy and also X-ray scattering, the approaches which we are using based on DFT calculations and other methods need to be, we need to continue to develop them, or let's say not we, but our colleagues in theory. And I think what makes it what makes it even, why that is even more important is what I mentioned in my talk briefly. A lot of interesting changes are very subtle. So we cannot just think of having like a qualitative overall agreement between like data and calculations, but we need to be able, because if we want to train these algorithms, right? So we need to train the algorithms to find these rare events. And how do we train them? We need to have good theory to train them on. And maybe you can comment on my comment.
Yeah, right. And I think that there is a lot to, so I'm always thinking about how do we combine now our theoretical developments with, different ways of doing things, at least different from what I was doing a long time ago. Now that machine learning and data and the use of data is in the picture, right? How do we combine our theoretical development, especially in combining spectroscopic method based on first principles? And I think this is a very interesting question. I don't have exactly the answer, of course. And your work, first of all, is beautiful. And second, is really pushing us in that direction of thinking of how to marry theory and data science in a better way.
Well, thank you. And we should maybe just continue to talk about that. Sure. So nice to see you on.
Nice to see you.
Yeah. It has been a long time when we met last at a conference.
All right, are there any further questions, either written or orally? I don't really see any. Yeah, so this was very interesting also to see. You're using the detector technology is now also being used, for example, with electrons. We use, for example, DECTRIS, which is very popular also with X-rays and has basically now somehow flooded our market as well, slowly at least. So there's a lot of overlap with that as well. Also with the time resolution that you get there in principle. Good. As I don't see any further questions and as we're already a bit over time, thank you very much again, Dr. Bergmann.
Thank you.
Yep, thank you.